Hello everyone and welcome to another problem solving session on Special Maths Academy. And in today's video, we're going to cover the fourth problem in the Junior Second Round Maths Olympiad 2021. And it goes like this. In a triangle ABC, okay, I'll just be sketching the diagram. In a triangle ABC, we have that, it's like C. We have like B and E are points on AB as this. Then we draw lines that cross together. And we have a point here called P. So the areas are like 5. I'm writing different color. 5 and 8. Yeah, respectively. So the question asks us to find the area of the whole triangle. So how can we now find the area of the whole triangle? The area of this whole triangle definitely is the area of this 5 plus 10 plus 8 plus the area of quadrilateral ADPE. Definitely. So in essence, what we just have to try to find is the area of this quadrilateral here, ADPE. Once we find out, add it to the numbers, the area is already given, and we get the area of the whole triangle. So a good technique, or there's a lemma we're going to use in this question now. So let me just write the lemma. Let's say lemma. So the lemma is if you have triangle or so like if you have, let me just say, if you have a line, let's use different letters from what's in the question, XZ, and you have like a point Y, let's say in between X and Z. Yeah. If you draw any triangle that has X and Z as its vertices, let's call another triangle here, let's call it Q. This is not necessarily a right angle triangle, let me change it. Not so confusing. You have, and this also not necessarily perpendicular. And just make it very look arbitrary. So if you have like Y to be any point, so far like this question, the fixed points are X, Y, and Z. X, Y, XZ is a segment, Y is a point in the segment. So any point P you have that is not on this line, like yeah, that forms a triangle to XZ, any point P, you have the ratio of the areas of this. So this sign denotes area. Is constant. Like regardless, like if you pick another vertex somewhere else here, let's call this P1, let's call this P2. Like regardless of the vertex P you pick, remember these points are not all cyclic, they are just random. Like let's call this P3. Like the ratio of the area of PXY to PYZ is the same, so it's constant. So that is a really powerful lemma, and it's used in proving a lot of facts in geometry and can also be used in like solving like some standard Olympiad problems. So we're just going to like easily prove that now before we go on to see how we can use it in our question. How can we prove this? Okay, yeah, so the idea of proving this is just like, it's very basic. We just have to remember that the formula for area of triangle is half base times height. So because these two triangles, PXY and PYZ, like they both share a vertex and like their bases are collinear. So we can just like draw a height here. From this point P, you can drop it perpendicular. So call it H. Like this line, let's call this foot of altitude, let's call it H. So this line segment PH is both the height is the height of three triangles. Is the height of triangle PXY. It's a height in triangle PXY. It's a height in triangle PXZ, and it's also a height in triangle PYZ. So that like is true because X, Y, and Z are collinear. They lie on a straight line. That was the initial condition. X, Y, and Z are collinear. So now, given this now, so now what does it mean? It means that the area of triangle PXY is going to be what? Half base. What is the base? PXY is this obtuse angle triangle. The base here is XY. Like the base of this height is like XY. So the base is going to be XY times the height is H. Like that's length of the H. Or let me write PH. Value of PH is smaller than H. Equals to half XYH. And similarly, the area of triangle PYZ is what? Half times YZ times the same PH, because PH is an altitude in the triangle also. And it's opposite like the base here. Because it makes 90 degrees with the base. So that's how we know which side is opposite the altitude. So this is what? Half times YZH. Now, when we divide this and this, like when we divide the area, so this is like what we used to denote area, like these brackets, square brackets. Because I don't want to start writing statements here. So when we do this, we see that half and H cancel out. And what are we going to be left with? We're going to be left with XY over what? YZ. And remember how the question was structured. X, Y, and Z were the initial conditions. They were fixed. So like regardless of the value of P, the ratio of their areas will be XY over YZ. And X, Y, and Z were fixed points. So the ratio is fixed. So that's why this ratio is constant. So as I said down, this is a really powerful lemma. Like, and you can use in a variety of questions. This is one of them. So we're going to use this to simplify this question. You know, some of us may be thinking, how can we use this to simplify this question? But we find a way we can apply it. We have to draw some extra lines. I'll show you in a minute. Yeah, let's go back to the question. So now, remember, this point here is point P. Yeah. So what we're going to do now, we're going to introduce this line here. In geometry, it's not really strange seeing us adding stuff to the original diagram. They try to like make the question as obscure as possible. So if you start introducing new lines or new points in the question, it's not strange. It's really, really possible that those new lines can help out. So notice that this new line, AP, is going to help out. So after we draw the line AP, we can now apply that lemma. So I'll just like draw it, because initially, if we're looking at this all together, it may be a bit complex. So I'll attach some parts that I'm currently dealing with to help us understand it better. So now, what I'm going to do, I'm going to like bring in two variables. Remember, the question, it suffices to find the area of this quadrilateral here, ADPE. So I'm just like going to say, let the area of triangle ADP, let it be X. And let the area of triangle APE, let it be Y. So yeah, this is what we have. So if we can just try to like find two non-equivalent equations involving X and Y, we can try to solve it simultaneously and see what we get. Next up now, let's look for a common, let's try and like see how we can apply that lemma. So this point AP and D is here now. Okay, let's look at this D, P, and C. Let's draw it here like this. So I say I'll draw it out. So this is D, this is C, this is B, and P is somewhere here. So this is P. Now I'll draw this line here, or this line drawn here. Sorry about that. Yeah, so this is a line we have here. We have this line here. And the area of this triangle is 5. The area of this triangle is 10 units. So based on the converse of the lemma, or based on the lemma, what does it say? It says that since like here D, P, and C are three collinear points, and P is in between like segments CD. So it means that the area of triangle, according to the lemma, I've cleaned it off. According to the lemma, the area of triangle DBP over the area of triangle PBC is equals to this over this. So the area of triangle DBP over area of triangle C BP is equals to what? Okay, like we're giving the explicit values of their area. So the area of triangle DBP is what? 5/10. This is not according to the lemma. This is according to what we are giving here. But according to the lemma, this is equals to what? It's equals to this over this. So it's equals to DP over PC. So DP over PC is 5/10. So it means that 1/2 equals to DP over what? PC. That's what we have now. So as that we see it here now, like you still be confused, like why I'm trying to find this. But this is where the lemma gets interesting. When there's more than one point, that like when there are like more than two vertices, more than one vertices that like have DC as a base. So if you look here now, this DC we have here. If you look at this DC we have here now, this point that I introduced, this new line, sorry, I introduced AP, climb completed. It's going to get a bit tricky, so I'll be using different colors. Now, this same DP over PC is going to be equal, according to the lemma, it should be equal to the area of triangle ADP over area of triangle APC. Because they share the same base. It's just like our P1 and P2 that time. Like any triangle you form, even the triangle had to be like this. So first, we are comparing. So first, we are planning to compare the area of a triangle that has this, the new vertex and the point P here, to see how the same ratio at is, because the base is equal. So that is the cool part about the lemma. Okay. So what does that mean? So based on what we did here, the area of this is what? X. And the area of this is what? Y plus 8. Remember, I didn't draw this extra line here because it was not necessary at this point. So this is Y, this is 8. The sum is Y plus 8. So according to the lemma, the area of the ratio of the area of ADP, ratio of area of ADP over APC is equals to 5/10, is equals to X over Y plus 8. So I found one equation that has X and Y as variables. So it means that 2X is equals to Y plus 8. So these are equation 1. 2Y is equals to X plus 8. 2X equals Y plus 8, not the other way around. So I'll be a bit faster in the second one because I just wanted to try and use this first one to fully explain how we can apply the lemma. So in the second application of the lemma, the line we are going to use will be this other one here. In this case, we use DPC. Here, the next one we are going to use is BPE. So let's use BPE now. Let's see what we get. So I want to use BPE. I'll draw it here again now. So I draw BPE first. B, E, P is somewhere here. Then next up, I construct this line like this. And yeah. And also have something like this. Sorry. Yeah, this is a bit hard to draw the diagram, but we'll have something like this. Yeah, so this is P. So this is P. This is what? This area here is 10. This area here is 8. And this is point P. I'm writing in a better place. So according to the lemma, okay, let me number the vertices. A D is not necessary at this point. This is C. So according to the lemma now, the area of triangle BPC over area of triangle EPC is equals to what? EP over what? PE. And in the question, like this area was given, so this equals to what? 10 over 8. So BP over PE is 10 over 8. Then next up, we're now going to like use the same base like it's constant. Like this A and C are just different points that share a constant, like a fixed segment BE. So applying that same logic, we're going to like get that BP over PE, which is the same like 10 over 8, is going to be equals to what? DP occurs first. So it's going to be equals to the area of this triangle A. It's going to be equals to APB over APE. So area of triangle APB is what? Is x plus 5. Because I forgot, I didn't add up this line segment PD because it wasn't necessary at this point. The area of triangle APE is what? Y. So it implies that 10 over 8 is equals to x plus y over x plus 5 over y. So these are second equation involving two variables. And from here, we just apply a normal knowledge in simultaneous equation. So from here, you can simplify this to 5 over 4 and get 5y equals 4x plus 20. So from here, what are we going to get? We are going to get that 4x is equals to 5y minus 20. These are equation 2, remember. These are equation 1. Okay, let me write down our two equations to see how far we have gotten. So our first equation is 2x equals to y plus 8. Our second equation, we can rearrange it to 4x equals to 5y minus 20. So these are equation 1, these are equation 2. So you can multiply equation 1 by 2. What do you get? Get 4x equals to 2y plus 16. And the same 4x is equals to 5y minus 20. So what do we have? We have that 2y plus 16 is equals to 5y minus 20. So get that 3y is equals to 36 and y is equals to 12. So when you get y equals to 12, we can plug in y equals 12 in the first equation. And what does it give you? It gives us that 2x equals to 12 plus 8, 20. So x is equals to what? 10. So x is 10, y is 12. So right now we are actually done with the question. I just have to add up a bunch of numbers together to see what our final answer will give us. So the area of this is 10. The area of this is 12. So when I add up to find area of triangle ABC, you just add up the area of all these triangles. So that will be the area of ABC equals to 10 plus 12 plus 8. I'm going clockwise. Plus 10 plus 5. So that will be 22, 30, 40, 45. So the area will be 45, whatever units they use here. Just 45, okay. We didn't add any units. So that's how to solve this question. The major idea here was to use the lemma and to like try to see how we can apply it in this question. Because like geometry can be a bit tricky sometimes. That's why it's good to like draw like multiple diagrams where you, in some of the other diagrams, you don't like add up everything that was in the original diagram. Like you can see things clearly. That's why I drew this and this. But in this place, I didn't add the segment PE, and here I didn't add the segment PD. So this is how we do this question. It was really interesting, and so my favorite question in this second round. So if you can come up with some other ways of solving it, you can write it in the comments in the chat session, and I'll be really interested in seeing if someone can come up with some other ways. Thanks for joining me today, and I'll see you some other time.